Today we are going to learn about optimized performance with Python generator expressions. We will explore how generator expressions can optimize code performance, focusing on memory efficiency and faster execution for scalable applications.
Welcome to our video on optimizing performance with Python generator expressions. In this session, we'll dive into the world of Python and explore how generator expressions can significantly enhance your code's performance. We'll discuss the importance of efficient code execution, especially in scalable applications, and how generator expressions can help achieve this. By the end of this video, you will be equipped with the skills to implement generator expressions for faster and more memory-efficient operations. Let's get started. Python generator expressions are a concise way to create generators, which are a type of iterable like lists or tuples. However, unlike lists, generators do not store their contents in memory. Instead, they generate items on the fly. This makes them an excellent tool for handling large datasets or infinite sequences. The syntax of a generator expression is similar to that of a list comprehension, but with parentheses instead of square brackets. For example, XX for x in range 10 creates a generator that yields the squares of numbers from 0 to 9. Generator expressions are particularly useful for improving performance in scenarios where memory availability is restricted, or when you are working with large datasets that do not need to be stored entirely in memory at once. List comprehensions and generator expressions are both powerful tools for creating iterables in Python, but they have distinct differences. The primary difference lies in how they store data. List comprehensions create a complete list in memory, which can be beneficial when you need to access elements multiple times. In contrast, generator expressions compute items on demand and do not store them, leading to significant memory savings. This makes generator expressions faster and more efficient for large datasets or streams of data. For instance, if you need to process a large file line by line, a generator expression would be more suitable due to its minimal memory footprint. Understanding the appropriate use cases for each is crucial for writing optimal Python code.
One of the standout benefits of generator expressions is their memory efficiency. Unlike a list, which stores all elements in memory, a generator yields elements one at a time, only as needed. This lazy evaluation strategy means that even if a generator expression produces a million items, it only computes one at a time, drastically reducing memory consumption. This is particularly advantageous when working with very large datasets or when you need to maintain high scalability in applications. Consider a scenario where you process log files from a server. Using a generator expression allows you to read lines one by one, ensuring your application remains responsive and resource efficient, even under heavy loads.
Generator expressions are versatile and can be applied in numerous scenarios to optimize performance and resource usage. They are ideal for data processing tasks involving large streams of data, such as parsing log files or processing data from web services. Generators can also be used to efficiently handle infinite sequences, such as producing an indefinite series of numbers or timestamps. In computational tasks where memory is a constraint, generators shine by limiting the memory footprint. For instance, when developing a data pipeline that processes and transforms large datasets, using generator expressions can lead to significant improvements in both performance and scalability. They are also valuable in scenarios where you need to integrate with other Python libraries that expect iterables. To effectively utilize generator expressions in real-world applications, it's important to understand their practical implementation. Let's consider a case study where you're tasked with processing large CSV files to extract specific data points. A generator expression can be used to read each line, filter it based on criteria, and yield only the necessary information. This approach minimizes memory usage and improves processing speed. Another scenario involves using generator expressions in a web scraping application to extract and process data in real time. By implementing generators, you can handle data streams efficiently, even under varying network conditions. When implementing generator expressions, it's essential to handle exceptions and edge cases carefully to ensure robustness and reliability.
Comparing the performance of traditional loops with generator expressions reveals some key insights into efficiency and speed. Traditional loops, like for loops, iterate over data structures like lists or arrays, which can lead to considerable memory usage if the dataset is large. Generator expressions, on the other hand, offer a more memory-efficient alternative by generating items on the fly. Benchmarking tests often show that generators perform faster in scenarios involving large datasets, thanks to their reduced memory footprint. However, traditional loops might still be preferable for situations where repeated access to elements is necessary. By understanding these differences, developers can choose the best tool for their specific needs, optimizing code performance and resource utilization. Generator expressions can be seamlessly integrated with a variety of Python libraries to enhance functionality and performance. Libraries like itertools, pandas, and NumPy provide excellent support for generators, allowing for efficient data manipulation and analysis. For example, using a generator expression with itertools can optimize data processing tasks by chaining iterators without creating intermediate data structures. When working with pandas, generators can be used to read large datasets in chunks, minimizing memory usage while maintaining performance. In NumPy, generators can generate data for large matrices or arrays, providing efficient resource management. These integrations demonstrate how generator expressions can enhance the capabilities of existing libraries, allowing developers to build more robust and scalable applications.
For developers looking to further optimize Python code, combining generator expressions with other advanced techniques can yield significant performance gains. One strategy is to use lazy evaluation in conjunction with caching, allowing frequently accessed data to be stored temporarily without consuming excessive memory. Additionally, employing profiling tools to identify bottlenecks in your code can guide optimization efforts. Understanding the intricacies of Python's global interpreter lock, GIL, and leveraging multi-threading or multiprocessing can also enhance performance in CPU-bound tasks. By following best practices, such as writing clean and modular code, you can ensure maintainability while achieving high performance. Staying informed about future trends and updates in Python optimization will keep you at the forefront of efficient coding practices.
In conclusion, Python generator expressions offer a powerful way to optimize code performance by improving memory efficiency and execution speed. Throughout this video, we've explored the differences between list comprehensions and generator expressions, highlighted their benefits in handling large datasets, and demonstrated their integration with popular Python libraries. By implementing generator expressions in real-world scenarios, you can achieve significant performance improvements, especially in resource-constrained environments. We encourage you to explore further and experiment with these concepts in your projects, as mastering these skills will enhance your ability to write efficient and scalable Python applications. Thank you for joining us, and happy coding!